It's been quite startling to us that swab samples show huge levels of lactobacillus, way more than anything we see in healthy controls.
Welcome back to our Live UTI free channel. My name is Melissa, and this is part 2 of our interview with Nick Parkinson, a scientific director and researcher in the field of recurrent and chronic UTI. In part 1, we discussed the urinary and vaginal microbiomes and the impact of probiotics. Here in part 2, we'll discuss how to interpret urine and vaginal swab test results. If you like these videos, think they're important, and want to support what we do, be sure to hit subscribe and tick the bell so you'll be notified of our future videos. Thanks again for joining us on this journey to making change in women's health. We get a lot of questions because of the limitations of culture. People assume that many things have been missed historically. Have you found any organisms in your research that are unusual that you wouldn't have anticipated finding in the vaginal microbiome or the bladder?
Yes, we were very surprised to find quite so many high-level bifidobacteria in our samples, and I think that they, in our opinion, certainly represent an emergent UTI pathogen. But it's going to take a lot more research before that will become accepted. But the other instances where we found bacteria that we weren't really expecting, we found in one sample a lactobacillus, which we weren't expecting at all. Plantarum was the exact species. And we'd never come across this before, and it was present in a urine sample in millions of cells per mil, which is very, very high. And we immediately did what any research will do and reached for Google instantly and found that this bacteria is only really known to exist in root nodules from specific plants. And we were sat scratching our heads for a long time to work out why on earth this would be in very high levels in a bladder. And it was also present in the vaginal swab sample as well. And we were completely perplexed until we started to find out that Caniston had actually produced a probiotic, Canis Flor, which used a variety of different lactobacilli, but this one specifically was the most prevalent part of that product.
Right.
And we were quite excited because it meant that without any prior knowledge, we were able to suddenly find out that this, not only could we tell the person what's in their bladder, but we could also predict what treatments they'd used and what particular probiotic they'd used. So that then sent us on quite an exciting chase to start ordering in as many probiotics as we could find, and to run them through our system to try and get an awareness of what we might find, and to be able to predict what people had been using, which again is an entirely different field to what we're trying to achieve, but it's also very interesting because there are so many claims about probiotics that we were suddenly able to answer. So firstly, what was in the probiotics? Was it really what was on the back of the packet? Were the levels similar to what was being claimed? And we found that for the large part they were, but we expanded out to not just probiotics, but to fermented foodstuffs as well. So we went to all kinds of different things. Kefir, I remember one of the products that claimed to be fermented and contained kefir and probiotics from that, we literally found to just be water, absolutely nothing in there at all, which we found quite scandalous. But we also were able to track people who were actively taking these products, and we even started doing stool samples with our technique, and showed that we could very readily find that people who were eating these things, taking them orally, we could find all of the probiotics appear in the stool samples. But quite often when they stopped taking the probiotics, they disappeared quite quickly.
With the oral probiotics, have you found them also in the vaginal microbiome or the urine sample?
And we find, especially if people are using probiotics which are designed as a pessary, obviously those seem to colonize a lot more. We haven't done very in-depth studies, but certainly with some people we have found a probiotic species still present at fairly robust numbers in vaginal samples many weeks after they've finished taking the pessaries. But it seems to be very much an individual situations. In some people, they seem to colonize quite readily. In others, not at all.
Right.
And so I think that whole field of research is wide open, and it's this kind of tool that will allow it to really take off. But I'm not necessarily sure it will get the backing of a lot of probiotic manufacturers.
Do you think it's possible that some probiotics work to prevent it while someone's using it because it prevents growth of other organisms rather than colonizing itself?
Yeah, that's absolutely possible. I think we haven't, as I say, done an exhaustive study, but where we see higher rates of colonization, it tends to be in women who've been on a lot of antibiotics for a long time. Now, again, we might be looking at a skewed population because those tend to be people who are very aware of the fact that they've decimated their vaginal and urinary microbiomes. And so they're doing something to try to repair that damage. But we find that where there are already endemic species which are fairly healthy, you don't tend to see colonization from the probiotics quite so much. And that's possibly that there's already competition for them. But it's very, very hard to know whether there might be something to do with the genetics of the host that's at play as well.
Right.
There are so many different factors that could be. These are just observations made on very small numbers, but yeah, we do see probiotics colonizing in some people over time, and we even see them spreading to the bladder as well in serious numbers for some people, and not at all in others. Yeah.
So that raises two questions. You mentioned the long-term antibiotic protocols. Have you done any research into how that changes the microbiome over time?
No. As I say, we love research and we'd love to do more of it. But there's only a few of us here. There's only 5 of us that work here. And with at the moment, we've got lots of ideas as to what we want to do. But our primary focus at the moment is on our commercial service and making sure that it is providing the tool that people who have been left invisible and suffering for so many years really need. We recognize that actually the technology that underpins all of our testing can be applied to so many other things. And actually we've got plans eventually to get into those, but we're having to be quite disciplined at the moment. And that also means with our research as well. We are actively collaborating with global leaders in urobiome research, and we've got a paper that's coming out at the moment. You can get preprints online, which describes our technique and the application to the healthy biome already. And then we've got plans for we've got a collaboration looking at E. coli and the comparison of culture versus our technique on people who have recurrent E. coli and relapsed E. coli infections. And then we've also got a third paper that's currently in process, where we're actually publishing some of our early data on what symptomatic patients look like. And going back to some of your questions as to what bacteria are we seeing that other people aren't, and what is the prevalence of the bacteria that everyone knows about, and how might that be useful to the community.
Yeah, we can add some of those links to the video description if they're available when we publish this. There's one more question about probiotics and good bacteria. Is it possible that an overgrowth of good bacteria could cause symptoms?
We think it is possible. We're not the first to think this by any stretch of the imagination, but I think the more we research and the more samples we get in from people who have got very chronic symptoms, the more we realize that the whole field is very nuanced, and probably more nuanced than anyone's really given it credit for. At one end of the spectrum, we're going to have people who are suffering from very obvious infection, from uropathogens, or even from obvious infection by bacteria that are not currently deemed to be uropathogens, but may in future be accepted as uropathogens. But at the other end of the spectrum, you see a lot of people whose test seems to just reveal bacteria that are accepted as being part of the normal healthy flora of either a vagina or of urine. So the nuance really is not just in detecting the species, it's determining the levels and whether there's something aberrant about the levels and the relative ratios that you see. And we really do see that. And it's been quite startling to us. that, especially in the vaginal swab samples, for example, we see a lot of patients that come to us, or sorry, donors, customers that come to us, and their swab samples show huge levels of a lactobacillus, and more often than not, it's Lactobacillus crispatus is the one that we see, way more than anything we see in healthy controls. Now, this is a species that's known to be beneficial. It sits in the vaginal tract and it happily excretes acid and reduces the pH of the vagina, so that it actually acts as a physical barrier to a lot of other bacteria to come in and grow, which is a great thing. And there are even probiotics that you can buy now, specifically for vaginal seeding of Lactobacillus crispatus. But we very quickly found that there are a lot of people where the Lactobacillus crispatus levels are so massive that it's actually outcompeted all other species. There's not another species in there, which is very unusual situation to see. We don't see that generally in healthy controls. There's normally a mix of a happy community of different lactobacilli and maybe some Gardnerella in there, but more often than not, it's fairly well matched. Now, we realized about 2 or 3 years ago that there is actually a condition which is semi-recognized by some gynecologists called cytolytic vaginosis, which is characterized by an overgrowth of lactobacillus.
Right.
And it's thought that the overgrowth produces way too much acid, which in the long term actually will ulcerate the lining of the vagina, and it'll lead to discharge, pain, irritation, inflammation, lots of horrible symptoms. Unfortunately, there's no real known cure for it. There are some ways to alleviate the symptoms by washing the vagina regularly with a sitz bath, or trying to use pessaries that might try to rebalance the pH slightly. But we're seeing this in a lot of people who come to us. And it's very obvious that this is a real phenomenon. A lot of gynecologists are still struggling to get their heads around whether this is or not, but we definitely see it. And intriguingly, we also see it to a certain extent in the urinary tract as well, where it hasn't been recognized and it hasn't really been discussed previously. And we think that there might be a correlate of cytolytic vaginosis that might happen in the bladder. And certainly we see people who have incredibly high levels of crispatus in their bladder, and who under cystoscopy have shown gross amounts of ulceration of the bladder lining, and also very low pH urines. And so we're speculating heavily that this is actually an unrecognized condition at the moment. But there's a lot of research that needs to be done to understand what causes it. And until we know what causes it, we won't know how to correct it. And before any of that, we need to know whether it's actually linked to the symptoms at all, or whether this is a complete red herring. So there's a lot to do, but certainly the tool that we've produced is starting to reveal some really interesting things that have not been reported before.
Yeah, it's a very interesting area of research. I think it may apply to many people based on what we've seen from our community.
And I going back to what I said before, I think we're seeing almost the worst of the worst cases at the moment, because we're such a new technology, and we're expensive by our own admission. We are expensive. We're a not-for-profit company. We're self-funded, but we can't offer this out as a free test as much as we'd ideally like to. We have to cover our costs, and it's very expensive technology. And so we try wherever possible to pin our costs to other advanced technologies that are available, such as the 16S RNA based technologies. Our goal eventually is to try to get our technology taken on board by the NHS, but that's a long-term goal, and there is a lot of bureaucracy that we have to get through before we get to that. But we would love to see our technique being made available to anyone who needs it at any time for free. But unfortunately, we're not at that stage yet. So we're left with the people who are so desperate to know what's going on with them that they're able to, they're willing to pay the money that we charge. And so we do see, I think, a very niche set of sufferers. And within that, we do see this phenomenon occurring more regularly than we would have expected by chance alone, I think.
Okay. We received a couple of questions from people who use catheters about whether the testing that you offer is appropriate for catheter users.
Um, I don't see why not. We haven't tried it, to be
Hmm.
completely honest. We have had a very interesting case study of someone in a nursing home where there's been a suspicion of a long-term UTI for years, and the nursing home staff used an incontinence pad which was designed to allow you to recover the urine sample.
Hmm.
We were slightly dubious about using this to start with. We thought that the prospect of contaminants were quite high, but because it was such a frank infection, we saw it very, very quickly.
Hmm.
And so that's worked beautifully. And we think that if that can work, I don't really see a reason why a catheter-based sample wouldn't provide fairly robust results. And again, it all depends on what the results look like. If it's E. coli and it's through the roof, I don't think anyone's really going to argue that that's not causing the UTI.
So we were speaking about healthy controls. Do you have any research that shows what a healthy control should look like in terms of the vaginal microbiome?
So interestingly, the healthy controls microbiome is fairly well researched and defined, and this has come from previous research on 16S RNA work.
Hmm.
And researchers tend to classify the healthy vaginal microbiome at least into one of 5 different classes, and they're called community state types. And most vaginal communities will be a mixture of different bacteria, largely different types of lactobacillus that are in there. Quite often you'll get Gardnerella in there, Corynebacteria, lots of other different things, but mostly it's going to be lactobacillus.
Hmm.
And the different community state types, they're dominated by different types of lactobacillus. So in this table that we're showing, you should be able to see that each column is a different set of results from an actual patient that we've looked at, a healthy control. So for example, the first column, which is under the community state type 1, shows a variety of different species that are present at different levels. So each species is given on a different row.
Hmm.
But in community state type 1, it's dominated by Lactobacillus crispatus, which is how you define community state type 1.
Hmm.
Community state type 2, which is the second column, an example of, is where the microbiome is dominated by Lactobacillus gasseri.
Hmm.
Type 3 is where it's dominated by Lactobacillus inners. And type 5, which is more rare, we don't tend to see that much, is Lactobacillus jenseni.
Hmm.
The slight oddity in all of this is type 4, which is where you see a microbiome which is dominated by Gardnerella vaginitis. Now, that is a slight oddity in that we know that high levels of that bacteria can also cause bacterial vaginosis. And
Hmm.
so it's unclear at the moment as to whether that's a genuine community state type for asymptomatic healthy controls, or whether
Yeah.
it's people who genuinely just have a low level BV infection. But we saw all of these very quickly and very clearly with our technique when we started to look at all of our healthy controls, which gave us a lot of confidence that what our tool is telling us actually matches what's already known. But what's also interesting is that we spoke earlier about the consistency between the microbiomes of the vagina and urine and the bladder. We see that the same community state types that are present in the vaginal sample are very often the same ones that are in
Hmm.
urine, and it's less frequent to talk about urobiomes
Yeah.
in terms of CST types, but I think actually it's just as relevant because it
Hmm.
seems that that's where, as most of your urobiome seems to be driven from your vaginal biome, it makes absolute sense that if you're carrying community state type 1 vaginally, it's probably going to be what you're going to find in your urobiome as well.
Do you know if these state types apply differently pre and post menopause?
Uh, Absolutely. So menopause is a really fascinating, well, not condition, but it's a fascinating time of life where uh, the microbiome, as you know, changes a lot.
Hmm.
And there's a lot of evidence to suggest that actually prepubescent and post-menopause, um, the vaginal lining is quite different in terms of the hormones it excretes and also
Hmm.
physical attributes. between that time during sexual activity, it seems that the vaginal lining actually recruits. It goes some way to almost actively farm lactobacilli as a protective measure. And so it will, led by hormone levels, it will start to lay down glycogen, and which is a chemical that certain lactobacilli prefer to eat as their foods and their energy source. And so when we get to, well, when women get to menopause and the hormone levels alter again, it seems that a lot of the glycogen that's excreted by the vaginal epithelia to recruit these lactobacilli, it disappears. And as a consequence, a lot of postmenopausal women see a real reduction in the levels of lactobacilli that are present, which can leave them prone to infection because it is a very useful defense mechanism when it's in place. And it also means that it can leave prepubescence in a similar situation as well. Right. So it's kind of fascinating, but it's again, it needs a lot more study and a lot more observation. But we really hope that this tool that we've produced is actually going to help clarify and just make the whole picture so much easier to understand.
That would be great to see. So let's talk about the digital microbiology urine and vaginal swab test results. How are the results reported? Are all organisms found listed, or is there a threshold below which an organism will be omitted from the results?
So yes and no. It's a slightly complicated picture. We try to publish every single bacteria that we find, but at the same time, we need to do it in a way that is meaningful, so that it's your data. People have paid money for this test. They're customers. They want to see every bacteria that's in there, and so that's exactly what we publish. But we don't want to publish a long tail of organisms that we find at very, very low levels. And also, the lower the level you go, the less the confidence you have that it was really in there in the first place and it wasn't a contaminant. And so we do put a threshold in place. We actually put two thresholds in place. We have like a hard kind of floor level, which is set by our bioinformatic software. And that means that if we don't recover more than a basic amount of DNA fragments for an individual organism, we won't have the confidence to say that it was really in there. So, for example, if we only found one fragment of DNA which matched E. coli, we would probably say that there's no real confidence that that was really in there, because one bit of DNA is not a whole lot.
Yeah.
We like to see the same organism being matched in lots of different fragments of DNA before we have a lot of confidence that it was really there. And so we do have this hard cutoff, which can't be changed. We can look at underneath it, but the customer can't. We then also have like what we kind of term a soft cutoff, a threshold, where we prefer to only publish results which indicate in urine cells, organisms that are there that over 1,000 cells per mil. That's still about 100 times more sensitive than a culture test would be for the same organism. And it's incredibly sensitive. But we do allow people on the results pages to remove that threshold, and they can look at anything that sits in that grey area between 1,000 cells per mil and our hard threshold that we don't allow people to go below, because simply we think it's misleading, and we don't have confidence that anything at that level is real. And so we don't want to tell people that they might have something that they really don't. And so confidence levels are very important, and we've thought long and hard about them. The confidence levels in the vaginal samples are different just because we get so much more material back. And so we generally set those at about 10,000 cells per swab. That sounds like a lot as a lower threshold, but most of the time we'll see, say, for example, in a healthy individual, we might see crispus at levels which are in the tens, if not, hundreds of millions of cells per swab. So it's really a very small fraction of what you'd expect to see in there that we're going down to.
Right. And if multiple organisms are identified, which I assume most of the time they are, do the results help determine which of them should be treated first?
Absolutely. And we have a bit of a mantra, actually, that, a lot of culture-based tests that we see results coming back from. And obviously, we're comparing our testing to culture-based all the time. in the NHS system, if a culture grows more than one type of organism, it's discarded as being mixed growth. Our mantra is that if it doesn't, it should be discarded completely, because there should be more than one organism present in virtually every sample. And so that really just kind of gives you an idea of how far removed it is from reality. We do see multiple organisms in general in a healthy control. Say a vaginal sample, we might see 5 or 6 strong signals for different species. We might see more than that. We generally find that in an infection that looks like it might be an anaerobic vaginitis, for example, we see that actually once you get what looks to be a frank infection, it almost opens a door on a lot of different organisms coming in. So we might have much longer lists, and the picture becomes more complicated. And we're very aware of the fact that these are long lists of organisms that people are not going to really be familiar with. And so we try our best to offer them in a way that makes sense. So if they are known or suspected organisms in pathology, either vaginal or urinary pathology, then we'll color code them differently. We have a traffic light system, so that if it's E. coli, for example, it will be shown as red. If it's something like a Bifido breve, then it'll be shown as yellow because it's suspected, but it's not known. All other organisms that are not suspected to cause pathology will be shown in green, but then there'll also be organisms which aren't normally associated with being in a vagina, and there's no real evidence either way, and so we'll have to color those in gray. We also try to provide a little kind of info card for each one. So if you mouse over each organism that's in your table, then you should be able to have a little pop-up bit of text which will tell you what's known about that organism in the context of either the vagina or the urine sample. Now, when you've got a database full of 4,000 different species, that's a lot of species to start trying to drain Google and trying to work out what might be relevant, what might not be. So there's by no means is our database complete for information cards, but obviously it's an ongoing process, and the ones that are most commonly seen now do have advice with them. And so it's advice that's not just aimed at the customer. We're hoping that the customer will then take these data and show them to a clinician, and the clinician is likely to be as bemused by this kind of data as anybody else. And so it's really it's our way of trying to allow anyone who reads it to make sense of it and to try to work out how that might impact on a diagnostic.
Right. And when it comes to diagnosis, what is your approach to treatment options and showing what might be most beneficial?
So we have a tiered approach. So we are constantly doing in-house testing for sensitivity. We can't do that based on our DNA, direct DNA sequencing. I think the future will come not too far away, where just from the DNA code alone, you'll probably be able to make very good predictions about what the sensitivity is of that particular bacteria. But unfortunately, the knowledge and the research just isn't there yet. But our tool will be ready, and we'll apply it as soon as it is known. But to back up our DNA-based approach, we're constantly doing culturing in the lab, where we're growing different bacteria from samples that come in. And because we know what bacteria we're looking for, we're able to provide the correct culturing requirements for that particular bacteria to get it to grow in the lab. We have a very flash piece of equipment called a MALDI-TOF, which allows us to provide an independent confirmation that that really is the bacteria that we're seeing, and it's not just based on the DNA predictions. And then we can expose it to lots of different antibiotics and grow it to see not only which antibiotics seem to kill off that bacteria, but also what level of that antibiotic is required to kill it, with the caveat that this is in a culture in the lab and not necessarily going to equate brilliantly to what's happening in a urine, in a bladder, in the urine, or in the vaginal context. But it does give you a guide for which antibiotics probably have no hope in hell of touching these bacteria. And so all that information goes into a database, and that sits behind your results, so that if you have a bacteria that comes up in your results, which is a known uropathogen, so what we call a red species. So again, E. coli or Faecalis or Klebsiella or one of those well-known bacteria, then we will automatically provide antibiotic results not for your particular strain, but where in the lab we may have tested 10 or 15 different strains of that bacteria, and we know which antibiotic generally is going to be most effective in that context. And so that will be published alongside your results.
Right.
But so that things don't get too confusing, we only give antibiotic suggestions for treatment where there is a known neuropathogen and it is present over a certain level.
Okay.
So that's where it's probably most likely to be the cause of the symptoms. Although, again, the argument for causality is a long and fraught one.
Right. And if a patient orders a test, do they have access to these recommendations as well, or only with the clinician's involvement?
They have access to these recommendations, and we have also got a service which will be coming online soon, that the way the system works, the way it's been designed, we would, for speed of turnaround, so that people can send us a sample, we can test it, 24 hours later, they can tell what they've got in their urine. Hopefully, they can then go back to their GP or clinician, and they can say, right, okay, I've got alloscardovium. And the lab says that this is the best antibiotic to get rid of alloscardovium. Can I have it? And then the clinician will make a judgment call on that information and decide whether to prescribe it or not. It may well be that our database won't work for some people. Then some people may carry individual strains. And remember, this goes back to what we were talking about the fact that the strain that you have in your bladder is probably unique to you. They might have strains that don't react in the same way that the strain we've tested in our lab. We're trying lots and lots and lots of different strains, so we get a much broader picture of how that responds as an organism, but there's always going to be the occasion when there'll be an exception to the rule. We are trying to start a new service which will allow people to actually test with us a urine test. And if, say, for example, they've previously had a urine test with us that shows Klebsiella, they've taken our treatment advice, the treatment advice hasn't worked, we will then grow their exact Klebsiella from their urine sample, and then we will test it with our barrage of 20 to 21 different antibiotics to say what their exact Klebsiella will do. But the problem is that process is slow and it will take several weeks. And so that's not what we want to do in the majority of cases. For the majority of cases where the generic information is going to be useful, people can get the antibiotic advice within 24 hours, which is what's most useful. And it's only in these very, very small section of people who, for whom that doesn't work, they can come back and then they can do the slightly more prolonged bespoke testing.
Okay. And right now, where are your tests available?
So we are exclusively online. So you have to go to digitalmicrobiology.com to order your test, and you'll be able to have an account there, which will securely track any tests that you've had previously and allow you to compare them directly. It can track your symptoms if you choose to fill out a self registration symptom tracker that we provide. We are able to offer postal home testing kits. So this is one of the beauties of our system, is that you order a kit, it's dispatched same day, normally within the next day it'll arrive at your home. If you've got a urine test kit, then you follow the instructions and you take your urine sample. It then comes back to the lab for the next day with guaranteed next day delivery on post. Swab samples are very similar as well. We started off by offering just a UK-based home sampling system, but we've now in the last month expanded that using FedEx courier services to enable us to actually reach out and offer this service to 27 different countries across the EU. The time lag between taking the sample and getting it back into the lab, slightly longer, but we've done a lot of testing on the preservative that we use in our samples, and we know that actually that journey time doesn't really affect meaningfully the sample as it comes in. And so we're now very confident that our EU service is there. The EU service does carry a slight premium for the postage because we're using FedEx door to door, but it does cover not just the journey for the kit to get to your house in whichever country you're in, but it also covers the FedEx journey to pick it up from your house and bring it back to our lab with guaranteed priority post.
Okay, great. We can add a link to the video description for anyone that would like to learn more about the testing available. And I just wanted to thank you so much for answering all our community questions and for joining me today.
Thank you very much. It's very exciting times, and we hope to be able to serve the community and help people out as much as we generally can.
We look forward to that. Thanks so much for watching. I hope part 2 of this interview provided new insights about organism identification and treatment recommendations for UTI. If you'd like to learn more about this or related topics, be sure to check out our other videos or head over to liveutifree.com for articles related to this video. We'll be sure to put some links in the description. If you like what we're doing on this channel, please support us by hitting subscribe and ticking the bell so you'll be notified of our future videos. Thanks so much for watching, and until next time, keep asking questions and pushing for better solutions.